The next two colligative properties that we're going to look at are closely related, which is boiling point elevation, and I want to point out the elevation. So elevation means to raise or lower, and the answer is raise, okay? So the boiling point of solution is higher than solvent, the boiling point of the solvent, okay? And so basically the amount that again, this is the change in boiling point, so it's the boiling point of the solution minus the boiling point of the pure solvent. And so it raises the normal boiling point of a pure solution by making a solution. So the formula is delta, or change in the boiling point, TB, is equal to KB. That's a constant that's solvent dependent, will be given to you, times Cm. So instead of using small case m versus large m, Cm is the concentration in molality. Okay? Compare that to the freezing point depression. Okay? And depression means that the freezing point of solution is going to be higher or lower than that of the solvent. It's going to be lower than the freezing point of solvent. And so this is going to be really important when it comes into here. So the definition is it's equal to the freezing point of the solvent minus the freezing point of solution. So that basically delta T, whether it be TF or TB, is always going to be a positive number. But the formula looks very similar except for the fact that I have F's for freezing. So KF, again, solvent dependent, and Cm. So the picture I have here is the fact that in the north they use salt and they put that on the roads to melt the ice. This one shows the fact that when I come back here, so again, this is the pure solvent, okay, and I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 molecules that are becoming, so this one's 8. When I add a solute, which in this case is the pink, when I add a solute to it, I reduce that down to 5 molecules that are in the gaseous phase. So it's harder to boil it when it's a solution. Okay? So, problems. Okay? It wants to know what the TB is, what's the boiling point, and the freezing point, so TF. And I have Cm, or concentration in molality, is 2.47 molal of naphthalene and benzene. And it tells me that the boiling point and freezing point of benzene are, so TB, pure, I'm going to still use the degree sign for pure, 80.1 degrees C. And TF pure, or degree, is 5.5 degrees C. And then KB is 2.53. And KF is 5.12. Okay? So the formula is that delta TB is KB times Cm. All right, so I have to find delta TB, and that was the boiling point of the solution, which, oh, I'm sorry, I'm supposed to find that. Never mind. Sorry, going the wrong way here. Okay, so I'm finding delta TB. So KB was 2.53. The molality was 2.47. And so that gave me 6.249 degrees C. Okay, so boiling point is raised. Okay, so that means I'm going to take the boiling point of the solution is the TB naught plus the 6.249. So it's going to be 80.1 plus the 6.249. Erase this. Plus the delta TB. and I get 86.3 degrees C. All right, for the freezing point, the formula is the delta TF is KF times CM. So KF was given at 5.12. CM is still 2.47. So I do that, I get 13.59 degrees C. And so the freezing point is less than, so I'm going to take the freezing point of the pure solution minus delta TF. So it's 5.5 minus the 13.59, and I get a negative 8.09 degrees C. Okay? So I highly suggest you try doing this problem on your own before I work it. Okay? So an aqueous solution containing the amino acid glycine. Assuming the acid does not ionize in water, calculate the molality of the solution. So molality is what I want to know. If it freezes, so TF is a negative 1.1 degrees C, and KF for water is 1.86. Now, you notice that I did not give you the TF of the pure because it's water, okay? And so I expect you to know that water freezes, so TF naught, you're supposed to know this, at 0 degrees C. Okay? So my delta TF is 0 minus a negative 1.1. So delta T always has to be a positive number, so it's 1.1 degrees C. The formula is that delta TF is KF times CM. So I have 1.1 is equal to 1.86 times CM. So 1.1 divided by 1.86 is CM. And so CM, or the concentration in molality, is 0.591. Okay? So I'm going to stop this video here. I've got one more problem to do, but that will be in the next video.